Good morning, everybody. My name is Jeff Allen, and I will be your host today. I am facilitating today's webinar along with my colleagues, Alessandra Milliken and Scott Newlis. Alessandra is Esri's Renewable Energy Account Manager, and Scott is Esri's Renewable Energy Solution Engineer. On behalf of all of us, welcome to our webinar on how you can best use Esri technology to assess project site visibility using location intelligence. I think you'll find our time together to be interesting, informative, and helpful. Before we get started, let's take a moment to check out the webinar control panel that's on your screen. I would like to encourage you to post questions as they occur during the presentation in the GoToWebinar dialog box. We will answer as many of the general questions as we can as time permits at the end of the webinar. Questions that require longer answers or have really technical questions that are better off answered by one of our specialists will be handled individually after today's webinar. If we can't answer all the general questions during the time allotted, we'll answer them in a frequently asked questions document, which we will distribute after to all attendees. Please also note that you could switch between telephone and computer speaker audio and adjust your screen to full or partial view. We are recording today's webinar, so that will be available as well. But for now, let me pass it over to Alessandra.
Awesome, thank you, Jeff. And thanks everyone for joining us today. I'm sure many of us are working from home and dealing with a bit of change of pace, so I really appreciate your time to attend today's webinar. So we really hope, like Jeff said, that you'll find today extremely helpful and that it provides you some sense of normalcy during these kind of weird times. At the end of this webinar, we will briefly discuss Esri's COVID-19 resources to assist in keeping your employees safe and helping your company maintain business continuity. But if you do have any questions or need assistance regarding COVID-19 resources or information we're going to cover today, feel free to reach out directly to us afterwards. So over the next 30 minutes, we will split our webinar into 3 short demos to discuss prospecting, land securing, and permitting and siting. So for your organizations, you'll know how to answer the following questions. What project sites have the most potential? How do we maximize designs to prevent disruptions and reduce project costs? How will our project impact the community? I know we're really concerned with that one in renewables. How do we stay on schedule? And most importantly, how do we deliver project staff the information they need no matter where they are? So we definitely understand that everything we're about to show is a very complicated process. So for the sake of time, much of what we're showing today is at a much higher level. And Scott will be focusing on a wind workflow today, but the ArcGIS platform can support any renewable energy workflow. And you'll find that there will be many parallels to the work you perform every day. So with that, let's get to the fun part. Time to hand it off to Scott, and we'll get started with prospecting.
Thanks, Alessandra. Finding the best location for a renewable energy project can be a difficult task. A lot of these factors determine what makes a site viable and really what doesn't. Using ArcGIS Pro, we're going to start off by taking a look at how we can estimate site viability of a proposed wind farm using some suitability modeling techniques. So we're going to start off at a national level and evaluate a few of the key data sets that we're going to use in our analysis. Now, the first and arguably most important variable in this whole ordeal is really wind resource. And so I've pulled in the wind speed class layer from the National Renewable Energy Laboratory, so we can really get a good sense of where the windiest areas are within the lower 48 and where the not so windy areas are. This is going to play a major factor into our final suitability analysis that we determine here today. Another important factor is transmission line infrastructure. Obviously, once we build a renewable energy project and start generating electricity, we need to get that electricity to the load centers and to the end user. So being close to existing transmission will greatly reduce project cost and increase time to market. Another factor is proximity to densely populated areas. Now, obviously, some of these more heavily populated areas, there will be a greater load for electricity, a greater demand for electricity. So we want to site our project somewhat close to them, but not too close that we become kind of a source of controversy in the community. And lastly, the location of airports also plays a critical role. In this case, wind turbines are very tall structures, and we need to really understand where we can and can't place them due to FAA regulations and other strict guidelines that we must adhere to. So I recognize this is only a brief and really condensed data set of all possible variables we might want to take into account. But when we start looking at all of them kind of overlaid on top of each other, we really understand and see how difficult it can be to really dive down to a specific location where we might be interested in putting a proposed location. So that's where this whole idea of suitability modeling really comes into play. Next, we're going to walk through a series of steps that looks at some of our tools for modeling suitable locations using some of these variables we've identified. And one great way to do that using our desktop tool set is through Model Builder. So suitability modeling at a high level takes multiple input data sets, it transforms them into a common scale, and then proportionally weighs them to compare them against one another. After that, a final score is generated, and that indicates the suitability of each possible location, referencing all of those input variables that we specified. So in this case, a lot of these input data sets are vector features. So what we want to do is create a raster data set from them. And that raster data set is going to allow us to classify the values, in this case, proximity to things like airports, transmission lines, and populated areas. And then what we want to do is reclassify those values for or into a common scale that allows us to compare all of these different variables. So for the airports, we essentially create a buffer around each airport location, and we assigned a value of either 1 or 5, depending on if the particular location was outside that buffer or inside that buffer. For wind speed classes, we just reclassified the original wind classification values. And then for transmission lines and populated areas, we used the same workflow that we did for the airports. So once we've got the data kind of transformed into this common scale, in this case, 1 through 5 rating, what we want to do is run all of those values through a weighted sum. And this weighted sum is going to allow us to proportionally weigh each of these variables according to their importance. So like I said at the beginning, that wind speed is the primary indicator for the viability of a project. So we probably want to weigh that one a little higher than maybe proximity to populated areas. So this is where we can come in and specify the weighting or the importance of each of these variables. And then ultimately, we'll end up with a raster suitability layer that shows us a rating for all of the possible locations. So once we run that analysis, this might be what we come up with. In this case here, I've got a raster data set for the entirety of the lower 48 region, and it's been symbolized according to that final suitability rating that we generated. In this case, the lower values are those red and orange colors, so those indicate a less suitable location, and those darker green values are higher values that represent a more suitable location given our input criteria. And we can really kind of ground truth this and kind of verify the accuracy of our model by using a proxy. So we'll actually use existing wind turbine locations to kind of verify the accuracy of this model. And again, we only used 4 input data sets. This might include 20, 30, or even 40 input variables to really fine tune the accuracy of this. But using just the 4 variables that we specified, we can see our model's not too off. You know, a lot of the current wind turbine locations actually fall within some of these highly suitable areas. So that tells us that our model is fairly accurate at predicting where potential or where sites that are potential for good wind development are actually located. So now that we've generated our final suitability results layer, what we want to do is go ahead and share this out with the organization. There might be a team of developers that is tasked with actually drilling down into this data set and finding specific sites to investigate further, and we want to enable those people to do their job more efficiently and effectively. So using some of the capabilities of our ArcGIS platform, we can actually share this data set out as a web layer. And since this is a raster data set, using our image server and our ArcGIS Enterprise capabilities, we can easily share this image layer out to be consumed within a web application. We can also use that same image server capability for the processing side of this as well. So this data set I ran, it only had 4 input variables, but it still took, a couple hours to execute all of the processes. If we scale that out to dozens of input variables and maybe larger areas of interest, then that could add up to a lot of hours, even days of processing. So using some of these image server capabilities, we can dramatically reduce some of those processing times as we offload those processes to the server tier. And so what I'm going to do now is go ahead and jump into our enterprise portal and take a look at what this layer would look like within a configurable application. So here we've built a basic web app using Web App Builder, and we've loaded in our suitability layer. The goal here is to enable the rest of our organization to easily use this layer not only for visualization, but also for further analysis as we go and dive deeper and find a specific site we want to use for our proposed project. Now, if I'm a different developer, maybe one that didn't create this particular layer, I may want to use my own criteria to model how I generate a suitability layer. And we can do just that using the image server and some of the out-of-the-box widgets. So here I've got our suitability modeler widget, and I've loaded it with just a few of those layers that we used to create this layer here on the map. And using this widget, in a few simple steps, we can actually create our own suitability analysis. So I'm going to choose to include all of these in my suitability model. And using the tools here, I can go through and specify the ratings and the weights of each layer accordingly. And all of these are interactive, so I can choose and really fine-tune the analysis that I'm performing. So I'll accept the defaults, and in this case, just assign some weights here. And once we total up to 100%, we can go ahead and run this model. And again, using image server, this is going to process lightning quick. So within a second, I've got my layer for the entire lower 48 symbolized accordingly based on the criteria I've set. And I can go in here and actually update this color ramp to match the first layer that I generated. So using just those 3 variables, we can see where highly suitable areas are in this darker green color. And this makes sense, right? A lot of our darker red colors are around airports or populated areas, so that makes sense. We wouldn't want to put a proposed wind farm there, but in some of these more rural areas with the higher wind speeds, they are showing up as very suitable. And one more capability of this widget is the ability to actually create an on-demand chart that shows a breakdown of these different classes within a given region. So I can go in here and interactively draw a feature here on the map, and it's going to generate a chart that shows me the breakdown of all of the suitability classes. So I can see here I've got a pretty high proportion of 7/8, so this might be a good location with a very small proportion of some of those very low suitable areas. So this is just one way that you might offload or modernize kind of some of your site suitability modeling techniques using image server and some of the web-based tools you have available to you. We'll go ahead and move along with the rest of the demo here. Let me turn this off. And we can see using that first layer we created, each point within this data set has that suitability results layer. These darker colors, it's a 4 or 5, and some of these red colors, it's a 1 or a 2. And so what we want to do is ultimately pull out those highly suitable locations. And we can do that just using a kind of a masked layer. So now we are We're dealing with only our highly suitable areas. And what we've done at this point is now received maybe a few areas of interest from our developer team that we want to focus on and investigate further. So our first area of interest is going to be over here in the Appalachian region. I can see a thin little strip of suitable area here, and we can go and verify this is a good area, again, by looking at those existing wind turbine locations. So I've got some here on the map, all of these red dots. So that indicates that this area is pretty suitable for development. And I've got this pretty big green swath down here that might be very tempting to us to develop. So I want to add a few other data sets to really explore this and see if this is a good site. The first one I'm going to use is a terrain data set. I see this is kind of a mountainous area. And right off the bat, I see there's a lot of very kind of steep sloped areas. So that might hinder us in our development or construction efforts if we do place a project here. So that's one factor we want to definitely take into consideration. Another factor is the presence of federal lands. So we want to be sure we're not too close to protected lands or looking at lands that we can't develop on. So right off the bat, I can see we've got some Forest Service lands and some Fish and Wildlife Service lands as well. So after just viewing those two specific layers that were actually coming from the Living Atlas, we can see that maybe this isn't the best location after all. We've got maybe too many factors going against us. So we can go ahead and kind of reject this first area of interest and move on to the next one. So the second area of interest is up here in South Dakota, actually. So it's a very windy area. We see there's a lot of suitable locations around here, even some existing wind turbine locations. And we're going to run it through that same kind of visual inspection that we just did with the first one. Starting with slope, you see this is a much flatter area. These darker gray colors indicate, much flatter area here on the legend. Same thing with the federal lands. We don't see a whole lot in the way of federal lands, so that's good. Now we're looking at a new layer here, wetlands. And what we do see are a lot of wetlands in this area. And so that might be indicative of a bunch of environmentally sensitive areas, maybe some endangered species. So that kind of tosses up a red flag right there. We can also verify kind of the species richness layer that tells us, if there's a lot of species in this area. This is actually on the lower end, so that's good for us, but there might be just too many wetlands to overcome this particular area. So for this case, we'll probably go ahead and reject this area as well. So moving on into our third and final area of interest, moving down here into Texas, we see we've got still some wetlands, but these are a little bit different. We've got some playa lakes in this region, and just from secondhand knowledge, we happen to know that those are dry most of the year, so there's not a huge hindrance there in terms of ecology and environmental. We can go ahead and look at our existing wind turbines, and we can see this area is very suitable for development. We've got several wind farms down here to the south and up here to the north, so that's a great sign. Federal lands, there are none, so that's another check in the plus column for us. And then finally, our species richness, we actually see there's a very low concentration of that as well. And then one more, we can look at our slope map and see, again, another very flat area, but we've actually got this ridge feature, so that looks like maybe we're on top of a plateau of sorts up here. So that's actually going to be favorable for us. As that wind comes up that ridge, we'll get some good wind speeds, and it's actually flat up here where we'll do the development and construction. So this looks like a pretty good location that we want to go ahead and focus on. And what we're going to do at this point is get together as a development team and kind of start investigating this a little further. And so that's when I'll toss it back to Alessandra to kind of wrap up this section.
Thanks, Scott. So in his prospecting demo, he showed how renewable energy companies can utilize their ArcGIS platform to develop an authoritative platform of data for everyone in the company to utilize, make available easy to use, interactive analysis tools that can be scaled to fit any workflow, macro and micro, and enable information sharing and collaboration for organizations. So now that we have our area of interest, that suitable location for our project, we now need to gauge the interests of local landowners. So Scott's going to move into our land securing demo to show you how you can use your ArcGIS platform to consolidate data and increase efficient project management, enable mobility and efficiencies in the office and out in the field, and track the status and progress of your projects.
All right, thanks, Alessandra. So moving along here, we've identified the area of interest, and we've created kind of a perimeter boundary for us here on the map. And what we want to do now is take a look at some of the landowner and parcel information in this area. As Alessandra just mentioned, we want to gauge the interest of our local landowners to see if they would be in favor of some wind development in this region. And really the first part of that is understanding who owns the land out here in this particular region. So I'm going to go ahead and turn on our parcels layer, and this shows us kind of a breakdown of all of the land tracts or landowners out here. And this is just a demo data set, but this information could be gathered from your local government agency, a county appraisal district or something like that. It could be gathered from a third-party data vendor or even a publicly available data source. So we can see we've got some good descriptive information. Again, this is all simulated data, but we've got a parcel number, we've got the name of the landowner, some address information, even a legal description. What we've done is go ahead and added an attribute in here, that's the status, and that's going to allow us to actually track the status of this particular parcel as it moves through this kind of land acquisition phase. And that's going to allow us to do some metrics and reporting later on as to the overall status of our project. And so once we've identified all of our landowners, really what we want to do is come up with a good course of action as to how we go out and contact these landowners and actually gauge their interest. And realistically, that's probably going to look a couple different ways. It's probably going to involve some actual boots on the ground, visiting with these landowners and having in-person meetings, and it's going to involve some digital communication, emails, even sending out mailers to folks that live in this area to receive communication from them. So along that first vein, what we want to do is enable our developers that are actually going to go out there and meet with our landowners in this particular region and give them the tools to collect information and see information about the project while they're out in the field. And our first tool to do that is our Workforce for ArcGIS tool. So as a project developer or a team lead, I may be responsible for a group of people actually going out in the field and the activities that they're going to be participating in. So using Workforce for ArcGIS, we can actively manage all of those activities. In this case, we've got some survey permission requests, some landowner meetings, and I can see here on the map where each of those activities are assigned to in terms of our parcels or our tracts of land. So I can manage not only the activities that we need to do, but also the workers I have out in the field. In this case, I've got a couple of developers and I can easily see their workload and also their status. And I've got a contractor and also a surveyor. So I'm able to manage and coordinate not only our activities, but also our workers while they're out there in the field and receive information back from them in real time. So we're able to track the status of the actual assignment, the status of the worker, and even communicate information to the people out there in the field. So for this particular landowner meeting activity, we've got some descriptive information. As the workforce dispatcher, I can even select and add attachments that might be beneficial to that worker while they're out there in the field meeting with that particular landowner. So let's go ahead and look at what our developers in the field might actually use to work through that process of meeting with the landowner. Here I've got my iPad pulled up, so let's imagine for a second I'm out there in the field and I'm seeing over here on the left-hand side only the assignments that have been assigned to me. So I've got 5 different landowner meetings, each at different parcels. It makes sense. These are still parcels that we're working with here. We've got some red, yellow, and green parcels that just symbolizes the status of our project. And for this particular assignment, I can go in here and not only see where the location is on the map, but actually click on that and get some descriptive information. So there's all of the details I see that was included by that workforce dispatcher back in the office. I can see he's included some attachments for me as reference here. So as I'm conversing with that landowner, I may need to pull up a sample lease document and actually talk through that with them. So this is a great way to reference that while I'm out there in the field. I can just pull this up and we can look through some potential terms of an agreement. And then back here at the assignment view, what I can do is actually communicate back to the person in the office what my status is. So once I'm ready to start actually working on this particular status, I can go in here and start it. So that's going to signify that I'm actively working on this particular activity. We can take action on that activity. So in addition to navigating to that location or pulling up a map and seeing what's around while we're out in the field, I can actually collect some information while I'm out there meeting with that landowner. So jumping over into our collector application, let's say we've met with the landowner and he's agreed to move forward and sign an agreement to be part of our project. We want to capture that information so we can go back and update the rest of our team on that. So using some of these tools, we can click on that same parcel here. We can get all of that attribution information that we were looking at back in the web map. And we can even edit the status of this particular feature. So in this case, I want to update it from negotiating to maybe acquired. We can go ahead and submit that. That's going to update the value and sync it back with the database. We can optionally come in here and add or edit any contact information. If we're meeting with the landowner and he says he has a change of address or something like that, we can capture that. But ultimately, once we've collected that information, we can go back here into Workforce. We can see that that update here on the map, and then we can go ahead and finish our assignment. So that's going to move that particular activity back to my completed list. And all I'm going to do now is move on to my next activity. I'm going to have the same information available to me so I can meet with that particular landowner and satisfy their particular requirements as well. So going back to our office view here, what we're able to see is that information be fed in from the field in real time. So if I go back down here, I see that landowner meeting assignment has been updated and it's been tagged as completed. So I'm able to stay on top of my my workers and my activities and really coordinate to get this common operating picture as to what's kind of going on out there in the field. So these are, this is a great way that we can enable our field workers with all of the tools they need. There's also going to be some people back in the office that are going to be receiving emails and even some hard copy mail that need to get information back into the system as well. So for those folks, we can go ahead and create another simple web application that allows them to do just that. So in this case, I'm going to go ahead and open up my email here, and I can see I've got a recent landowner meeting. Oh, let's see. I'll just go ahead and open it up here. Oh, drag it over here. 1 second. All right, so let's say I received this email from a landowner saying they would like to have a phone call to discuss the details of an initial email that I sent to him. They've included some information on how to contact them. Let's go ahead and use this information to get it back into the system so everyone can be on the same page. So using this particular application, I can go in and search for that landowner, Robert Kern. There he is. We know he's part of our project here, down here in Texas. And I can see this person hasn't really been contacted yet. And there's also some contact information associated with this particular parcel. So what I want to do is update this information with the information I received through that email. Using some of the editor tools here within the web application, I can do just that. And come down here, I can see this related record. I can come in here and update that phone number. So in this case, 806-231-4143. Notes, He wants a call at 10 a.m. tomorrow, which is 3/27. And I can even optionally include that attachment or that email as an attachment. So now anyone who pulls up that particular record will be able to see this email. I can go ahead and save that out. I can go back to the actual feature, and I can even update that status. If we have another status we want to move it to, like contacted or something like that. And that's going to update the feature across all of the maps that are looking at that. So now if we go back, let's see here. We can see, one great way to interact with our information coming in from the office, but we've also got the information coming in from the field. So what we want to do is be able to create kind of this one-stop shop that provides this common operating picture as to the status of our overall project. And for that, we've configured this operations dashboard that shows at a very high level some key metrics of our project. Again, since we want to focus on this Caprock project, I can go ahead and filter that out, zoom to it on the map, and we see our dashboard update accordingly. So we can see exactly how many parcels we have in this proposed project boundary. We can see a breakdown of what's been acquired, what's still negotiating, what's been rejected. If we're interested in filtering out one of those subsets, we can do that just to increase the focus here on the map. So I'm interested in those parcels that we're still working to sign here. And I can see a breakdown over here on the list. I see this guy right here, 1,700 acres. That's a pretty big chunk of my project. So I want to zoom into him and ensure that we dedicate more resources to this particular landowner and this particular parcel. So this dashboard provides us a great way to come in here and get a high-level overview of the status of our project, track individual parcels as they progress through this acquisition phase, and then provide some metrics that we can report on. Alessandra?
Awesome job, Scott. So now that we've utilized our ArcGIS platform in our land securing demo to streamline project management, ground truth information in and out of the field through mobile efficiencies, and track the status of our projects, we're now ready to move to the next step, permitting and siting. So before the project can move forward, we do need to collect data on wind speeds. So in this demo, we'll now utilize our ArcGIS platform to integrate additional data, model our project in real-life conditions before any construction even begins, and perform visualizations of our proposed projects. So these workflows will help us better understand the long-term viability of the site and draw in investors. So if you're working at home with your family, now is a really good time for them to walk by the computer. You can impress them with what you do every day. So Scott, let's go ahead and look at how optimal placement for our company's Met Towers can make sure this project site is truly a viable area of interest.
All right, sounds good. So now that we've kind of worked on acquiring some land, what we want to do is really figure out where the best locations for our Met Towers are, so we can really gather some good wind data to prove that the site is going to be viable for us. And this might occur before we do a lot of the other land acquisition activities. We might start with just a few easements to go and erect those Met Towers. But here are a few ways that you could potentially work with that meteorologist on figuring out the best placement. So we see here we've got a lot of our green, our acquired land. So we're going to use that to evenly kind of distribute out our Met Tower locations. And again, this is going to be in harmony with a meteorologist, either maybe someone you have on staff or someone that you're consulting with. But really, we want to get a good distributed wind characteristic profile of this particular project, so we really understand what the economics and financial impacts of this project are going to be. So since we've got some ridges to the south and east here of the project, we want to make sure we put some towers kind of close to that so we can get some of those characteristics. And then back over here where it's a little flatter, we want to also make sure we capture some of that information as well. So using our current locations and all of the other data we've kind of acquired up to this point, what we want to do is provide an interactive tool now that allows us to go at any point during this long-term local wind resource study and be able to monitor and get a real-time view into the current state of our project. So using our new experience builder, web application tool. What I've done here is create an interactive and kind of highly performant web application that does just that. Over here on the left side, we see a 2D map of those Met Tower locations. And then over here on the right side, we see a 3D view of those locations as well. So as we zoom into one of these particular locations, we can actually get a good sense of how that looks in 3D. And the reason we want to view this in 3D is not just to see the tower representation, but we have a bunch of sensors on that tower. And those sensors are what we're actually interested in. We want to see what the status of each of those sensors are. You know, as the project goes on, you know, these could be 2, 3, 4 year long studies. So as we're going through that period, we want to make sure that if a sensor goes down or it gets damaged in any way, we're alerted of that immediately, so we can go out and make the repair and ensure that we don't lose any valuable data collection. So in this case, we can see we've got 5 towers or 5 sensors on this particular tower, each at varying heights. We've actually got a semi-realistic model of a tower in here, so it looks pretty realistic as to what it might actually look like there out in the field. But what I want to do is be able to drill down into this particular tower and see the status of each sensor. So over here on the map, I know this is tower 1051. I can see that here on the list. I can update the sensor list based on that tower selection, and I can see I've got 5 sensors right here. They've all got this active flag attribute. So 1 is active, 0 is not. And I can actually come in here and see which one of these sensors is not currently reporting. So for this tower, I see they're all green, which is good. But if I zoom back out, I can see some red dots over here on the other side of my project. So let's go and zoom into this one. This particular tower is 1283. I can go ahead and highlight that one. And I can see I've got a 0 flag on my 30-meter sensor. So this immediately allows me to kind of diagnose the problem, see spatially where that issue is, and get some important attribute information, you know, the orientation, the boom length, sensor height, any of that rich information I'm going to need to make a more informed decision. So outside of the kind of 3D capabilities, we can also incorporate some real-time information into this view as well. So as I zoom out, we want to stay privy as to what's actually going on out there in the field in real time. And to do that, we've pulled in some current weather information. So up here, I've got some current weather conditions. This is just coming from a nearby airport, but this could easily be coming from one of those sensors you have out there on site. And we can immediately see the temperature, the current wind direction, the wind speeds, and any significant weather warnings if there are any. Over here on the map, we can actually zoom out and we can see kind of a regional distribution of some of those local wind or weather condition sites. So we can see things like you know, pressure, temperature, wind speeds, but we're also layering in severe thunderstorm watches and warnings as well. So again, this is just coming from the Living Atlas. This is just a freely available data set that we've added to our application here, and we're able to see exactly what watches and warnings are going to impact our project. So as a severe thunderstorm moves in, you know, if there's any warnings that get prompted, we'll be prompted of that here within this application and be able to dive deeper into the details of those watches or warnings as they develop. We can also see we've got some weather radar information here added to the map as well. So this is a pretty detailed, pretty interesting map that gives me a lot of information, not just on the status of my assets, but the status of the surrounding environment as well. So once we've really understood the wind resource, the localized wind resource of this area, and prove that this is a viable location for our project, what we want to do is go ahead and move into kind of the layout and design aspect. And this involves a lot of permitting, a lot of repetitive scenarios and design scenarios. So there's a lot of tools here that you can take advantage of that allow you to work through this process. First, what we've done is identified all of the constraints within this region. So constraints could be geographic features, existing infrastructure, existing, you know, our occupied structures that people live in. So we want to be sure we are able to map all of that information and get it into the system so we can perform the correct analysis. And this data could be collected from a field visit, could be digitized from the map, or any combination of the two. What we see here on the map is we've got some structures up here, mainly clustered in the top left. We've got a lot of those playa lake features. We've got some local kind of dirt or county roads, and we've got some irrigated agriculture as well. For each of these features, we may have a company standard or setback policy of setback distance that we must adhere to from that particular feature. So for an occupied structure, it might be 2,000 feet. For an unoccupied structure, it might be 1,500 feet. For a lake or a water body, it might be 300 feet. Whatever your internal organization has come up with, we can adhere to those standards and actually use that in an analysis to create these setback distances. So running just a basic buffer operation, we can generate buffers from all of those features using that setback distance and merge all of those buffers into kind of this final buffered out layer. And really what this layer symbolizes are all of the locations where we can't develop, right? They're too close to a structure, they're too close to a water body or an irrigated field or whatever it might be. So using this information and the boundary of our project, we can actually run some more geoprocessing tools and generate all of the suitable areas or areas that we can develop. And so looking at this, now we have a much better understanding of where we could potentially place a wind turbine, a lease road, a substation or a field office, or any of those facilities we're going to need for this particular project. So once we've identified all of the areas we can develop, what we're going to do is come up with an optimal location of wind turbine locations. And this might be done in a specialized software, and we might export that information back into GIS. There are some tools that allow you to do some of this modeling within GIS, but it's really your preference as to how you come up with these locations. Once we've got them, we can run some of those same concepts to identify other layout and design parameters or requirements as well. So using information like wind directionality, wake effect, rotor diameters, from a particular model that we're going to come in here and use in this project, we can generate these buffers that represent kind of our turbine spacing. So in this case, we've got buffers for 1 rotor diameter and 2 rotor diameters, right? So given our wind study, we see a lot of north-south wind directionality, so we can kind of place these locations much closer horizontally, but maybe a little further apart vertically. And so using some of these buffer tools, we can visually much better understand that through some of these different visualizations. Same concept for the row spacing. So in between turbine rows, we're looking at 5 or 10 rotor diameters here using a 90-meter rotor diameter and also a 5-meter or 5 rotor diameter setback as well. So these, again, just all help us to better understand how we're actually going to lay out the turbines in an optimal design given the different parameters and constraints we're working with. And there might be some other things we factor in, like those that parcel information. So as a new parcel or piece of land becomes available, we might add or remove some locations accordingly. So finally, what we want to do is run through kind of a visual impact assessment or a shadow analysis to see what the impact is going to be on the surrounding community. And to do that, we're using some of our web scene technology. This is just another configurable app that we built. But what we've done is added in some realistic looking wind turbine symbols. And we can kind of pan around this web scene here and see it's pretty responsive. And this gives us a really good idea of realistically how it's going to look like out there at our particular project location. So we've identified an area of structures, and we want to see how these structures are going to be impacted by shadow flicker or by some other visual impact from our proposed turbine locations. So if I swing this around here, we can see we've got a turbine placement right out here, right outside of the setback area. And we can go ahead and verify the measurement. First, let's go ahead and look and see if this is really an accurate representation. So I'll go ahead and measure from the hub height down here to the ground. And we can see, let's switch this over to meters. That's about an 80-meter hub height. So that's pretty realistic for this particular project. That's what we've identified. And that's what we're looking at here with the symbol. Now let's zoom back out and let's take a new measurement from the base of that location to the nearest structure. What we're able to do here is really generate how far that location is from the structure. We see it's outside of the setback boundary, but this is going to really play into that shadow flicker, that shadow analysis that we want to do. So really understanding the difference. I'm sorry here, thought I closed that out. I guess I did. All right, so using some of the setback distances here, we can better understand how this shadow impact is going to affect some of these surrounding areas. Again, using another configurable widget, we can come in here, we can actually set the current day and see how these shadows might realistically look. So it's March 26th. We can go ahead and enable the shadowing effect. And for each of our features on the map here, a shadow is generated based on the sun angle and the azimuth calculated for this particular time, this particular day. So using this interactive time slider, we can actually see how those shadows are going to change throughout the course of the day or over the course of the year. So here in March, we just had the spring equinox, so the sun is getting higher in the sky. So we can expect these shadows as the sun kind of comes in from the south are going to get shorter and shorter from this particular perspective. But what we want to do is really understand if these structures are going to be impacted at all. So we can go ahead and set this date for late in the year when the sun is very low in the sky. So we'll go ahead and pick December. Since we're in Texas, pretty low latitude, we'll go ahead and pick pretty close to the winter solstice here. So we can see those shadows grow just because of the angle of the sun. So again, using the same time slider, we can see how that's going to look like at the early morning hours, and we see that shadow gets pretty close to that structure. Then throughout the day, as the sun sets, we can see it come in through the other side. So this is just one way we can have this kind of interactive shadow analysis using some of these realistic 3D symbols. If you would like, you can load some realistic structure symbols in here as well. I've just got these kind of generic barn-looking symbols, but you can get some pretty realistic and pretty accurate measurements here using a tool like this. There are some other capabilities and tools that allow you to do like total shaded area and stuff like this, or stuff like that, but this is a great tool for that more interactive analysis. So with that, I'll go ahead and throw it back over to Alessandra to wrap us up.
Awesome, thanks, Scott. So Scott just showed us prospecting, land securing, and permitting and siting workflows using the displayed Esri products. So I know some of us are getting close to lunch or maybe second breakfast. You might be hungrier than a T-Rex in a salad bar, but now is the time to pay attention. If you liked any of those workflows we showed today, this screen is going to be of particular interest to you. So any of those workflows, I know, a lot of my clients have these products, and feel free to screenshot this. We are recording this webinar. We're happy to send it out. But if you want to bring any of these workflows into your organization or improve upon what you're already doing, please feel free to reach out to myself after this webinar, and Scott and I and our Esri partners are more than happy to help you make the most of your Esri investment in the renewable energy space. So with that, we will go to questions.
Awesome. Thanks, guys. That was really, really great. And we've got some good questions that came in through the webinar. So first question, Scott, I'll pass it over to you. What was the source of the wind speed data that you showed initially on some of that site selection?
Yeah, good question. So that particular wind speed layer I was looking at, we actually downloaded from NREL. So they make their data available at different heights. I think that was a 50-meter height, so it was a good approximation of what the wind resource looks like. But depending on your area, you might be able to get some more accurate data depending on what particular hub height you're looking at. But NREL, they're a great data source. They make their data available in a variety of different formats. You can bring that into ArcGIS. You can do some analysis like we did, or even share it out so you can collaborate around it with other people.
Cool. And how about those existing infrastructure, like the existing wind farms and solar? Is that stuff coming from the Living Atlas, or was that from another source?
Yep, so it's a combination of the two. That existing transmission layer and some of those federal lands, layers, wetlands, all of that content is available through the Living Atlas, which has a ton of great data layers that you could use in an analysis like this. Some of the other information, like the current wind turbine locations, you can get that information from the FAA. As they permit out those locations, they make it available. And you can download that and create a layer from it, or there's a couple of other different sources out there. But generally, all of the data that I showed today is pretty widely available.
Cool. And then another question was, is it possible to get that wind sensor data and back into ArcGIS Pro and do some different evaluation there?
Yeah, absolutely. So that particular wind sensor layer we looked at, that was just a point layer that had an XYZ value associated with it. So we're able to extrapolate it out in that 3D space and do some of that 3D visualization. But on the back end, it's a feature layer, so you can bring that into Pro and you can do some stuff with it. If you want to connect it up to, maybe you have a real-time data feed actually coming from those sensors, there are a variety of ways that you can actually connect that GIS feature layer up with that data, so you're able to stream the data in and do some analysis and kind of real-time visualization there as well.
Cool. And then one of the other last technical questions was, how would you, in your initial analysis, how would you have taken into account existing wind projects?
Yep. So that would have been another layer that I used in that initial suitability modeling. And there's a couple of different ways we could do it there. We could do kind of an existing wind farm boundary, and that might be a point or a polygon layer. And we would likely create a buffer out from that layer. So whatever standard you want to use, 50 rotor diameters, 100 rotor diameters, whatever it may be, create buffers around those existing locations, and those would kind of represent those less suitable locations. So at that point, it would just be another criteria that you would factor into that suitability analysis, associate a ranking or a weight to it, and then it would be included in that final output layer.
Cool. And I know we showed a lot of different data layers today, and I know there's a ton more. Is there a place these people can go and see kind of a comprehensive list of what we've got out there in the Living Atlas?
Absolutely. So the Living Atlas is accessible a couple of different ways. One, you can just do a Google search, Esri Living Atlas. There's a great user interface that pops up and allows you to browse through all of the different data categories. You can search for keywords or item tags and search for a particular layer. If you're within ArcGIS Pro and you're connected to one of your ArcGIS Online or portal organizations, you can actually bring in the Living Atlas data through there and look at it within Pro. And then if you're within a web map or a web application, you can also do that search and browse directly through that interface as well. So a couple of different ways to access it, but it's all built off of the same information. And like I said, it's a rich kind of collection of content that could be used for a variety of different sources. So I encourage, if you're interested, I encourage you to go out there and just kind of sift through the Living Atlas and see if there's anything that might be usable to you.
Cool.
And to add on to that, Scott and I manage our renewable energy industry, so we're always trying to help everyone on the call, maximize their investment and really work specifically with renewable energy workflows. So one thing we have been doing, we get this question a lot, what layers are in the Living Atlas specifically for renewable energy? We're trying to put together kind of a comprehensive list of the layers that we see most often used, just so they're in one place that our community can access those and not have to search and replicate workflows.
Cool. And I know, Scott, most of our demos were sort of North America, US focused, but that Living Atlas covers international as well.
It does. There's a lot of content in there from countries outside of the US, and it really varies by region. But again, I encourage you just to get in there, kind of search for what you're interested in. There's different ways to filter out by state or by geography as to kind of what gets returned in that search. But again, just another great place for you to kind of search and look for some information that might be valuable to you.
Yep, cool. And then sort of the last one, I'll pitch it over to you, Alessandra. I get a lot of folks asking, kind of how do I get started? Are there classes available? Or, I think, Scott, just to confirm, everything we showed today was really sort of out of the box technology, correct? Just configurable apps and maps using the core platform.
That's correct. Yep. No, there's no coding or customization that went on here. It was all out of the box tools.
Cool.
Yeah, and we're here to help you. We're your account team. For most of the people on the call, I recognize a lot of the names. Obviously, my contact information's on the screen. Feel free to reach out. We'll be sending this recording afterward that you can go through or share with your coworkers. But bottom line, we're here to help you. We're here to take the Esri technology you have, the problems you're facing every day, and kind of make that connection. So, definitely build up that community for the renewable energy industry. And we do have a massive wealth of Esri partners. I know a lot of them have been on the call, so thank you all for joining. They're here to help as well. And Derek Nelson actually just messaged me. He said there is a 3D class available that kind of specializes around spatial analysts and pro. So they do a lot of the same analysis that we showed today: routing, overlay, proximity, site suitability, 3D, et cetera. So, a ton of resources. If you don't know where to start, reach out to me and I'll point you in the right direction.
Cool. That's what we had for questions. There's a bunch that came in sort of last minute here. We'll put those together on an FAQ and be able to publish that out to everybody that attended today. Alessandra, I think you had a couple more things you wanted to add on the end.
Yeah. So again, I know strange times. So given the timing of current events and the COVID-19 pandemic, we did want to let you know that Esri has significant resources that are working around the clock. So we are assisting several customers, not just in the renewable energy industry, but around the world. So you're not alone. We're all in this together, and we have been working with some renewable energy companies to do a lot of things. So for example, using the COVID-19 data to build a company-specific hub around this to better understand the potential impacts across your organizational footprint or operating area. We are kind of a field-driven business a lot of the time. So if you are still sending employees out in the field, we have resources available to help you monitor their safety, and contractors. You can, layer on proximity to outbreak locations or available hospital beds. So feel free to use these resources. Reach out if you need any implementation support. We're all really proud to work for a company that really assists our customers during this time. So if we can be of any help complementing your internal efforts, please reach out, and most importantly, stay safe. But thank you all again for your time today. We really appreciate it.
Yeah, thanks everybody.